So now imagine we have a ball falling to the ground. We know its mass, this is our 2 kg ball, and we know its energy in joules. So let's say it had 60 joules of energy before it hit the ground. Now the question is, at what speed did it hit the ground? So we're only given a mass and a value for energy. So let's look at the two formula we know to calculate energy. We know that we've got gravitational potential, and in order to calculate that we need mass and the constant gravity as well as height. We know that for kinetic energy we need a mass, a value for mass, and here's our velocity. So the question is, at what velocity does the ball hit the ground? So here's our velocity unit. So we need to use this equation here. Okay, so can we calculate the velocity of the falling ball now? Well, I guess we can, because we've got energy. We've got a value for energy, which is 60 joules. We've got the mass, which is 2 kg. Only problem is the velocity over here is multiplied by the mass. So we need to rearrange the formula to get velocity on the other side of the equal sign. So this is where we use our triangle again. So let's construct our triangle, because mass, velocity squared and the half are all multiplied together. They must stay together, and we'll put them there at the bottom of the triangle. So here we go. So we go half m velocity squared, and on top we've got EK. So now we need to cover up the V, because that's the one we don't know, and the triangle tells us that we need to divide the energy, EK, over half mass in order to find velocity squared. So let's go and write that out in full. Let's go ahead and write that out in full. So the formula tells us, by rearranging with the triangle, velocity squared equals EK over half mass. So EK, the energy, it was 60 joules, and half the mass, so you should write that out in full. Mass is 2 kg. Running out of room again. So we're almost there. So if we start solving for this, 60 over 0.5 times 2 is 1, which gives us velocity squared equals 60. So it feels like you're finished, but this is where I'm going to warn you that what you've actually done up to this point is solved for velocity squared. Alright, so what we want to do is find the speed of the falling ball. So that's velocity without the square. So to find the velocity, we need to undo this square. So the opposite, or the inverse operation, is a square root. So you might remember that from maths. You just take the square root, and you'll have to use your calculator at this point. And if you've done that, you've done the square root of 60 in your calculator, it'll give you 7.745. Now this is also where I'm going to tell you about your decimal places. Just put 2 decimal places. So that last decimal, the third one was a 5. So anything 5 and above you round up. So we're going to make this 4 get rounded up to 5, and that means the final answer, just move this up one more time, final answer is going to be 7.75 5. And what were we measuring to begin with? If you've forgotten already, it was the velocity, so meters per second. So our original ball that was falling, our 2 kg ball that was falling with an energy of 60 joules before it hit the ground, fell at a speed of 7.75 meters per second.